What's going on, everybody, and welcome to a tutorial series on TensorFlow.js. Yes, I did do recently a live stream with TensorFlow.js. We'll be covering the exact same stuff, only in the tutorial videos things are much more condensed and hopefully a little more polished. So the first thing to talk about is why TensorFlow.js? Why is a guy who mostly programs Python interested in TensorFlow.js? Why might you be? So TensorFlow.js is like not really a competitor to TensorFlow and Python. They're going to work together. The thing that TensorFlow.js is offering you is deep learning in the browser for users with no installs required, right? That's the power that TensorFlow.js is bringing you. Now, the problem is, while it is fairly quick, it's not faster than TensorFlow Python. And I'm not really, it could be foreseeable that it could become just as fast, but it's unlikely, I think. But here are some. Here's a quick speed chart. Basically, this is a single inference. I honestly forget what it is. I think it's object detection, but it's not important. What is important is just comparing the speed times of a single inference between all of these things. So this is with TensorFlow Python on running on CUDA with a 1080 GTX GPU. Inference time, so like a single prediction, takes less than 3 milliseconds. On TensorFlow.js, on the same computer, it takes 10.8. So somewhere between 3 to 4 times faster if you're running it, natively, not in your browser. But this is still pretty darn fast. Okay. Now TensorFlow CPU, the delta is even less, where it's 56 milliseconds versus 97. So not even twice as fast if you ran it just on your computer. So for inference, it's really probably, your users, like even in this case on a CPU, that's less than 100 milliseconds. So you'd still be, let's say 10 frames a second of object detection. I'm not sure what else you would need a really, really high resolution or high inference rate for, but that's still pretty darn good. So, and probably over time it'll get faster. So this is done using WebGL, which is not the most efficient, not the newest technology, and honestly doesn't have nearly as much love as something like CUDA does. So I imagine that as time goes on, we will see significant improvements here. So what's the big idea with TensorFlow.js, right? So my expectation with TensorFlow.js is the main use case is going to be just transfer learning use cases. So you could, because of these deltas here in the training times, like this is on a single inference. Now imagine a batch size of 64 multiplied over millions of samples. Well, that difference is going to be very significant. So I don't think we're going to be, at least as long as the differences are here, I don't think we'll be training large models on TensorFlow.js, but there's no reason to believe that this time difference won't shrink dramatically. But the main thing to me is like with transfer learning, but also just in a business sense, this kind of opens doors that we've really never seen before. So traditionally, let's say you've got a machine learning model that you really want to use for, and share with people. Well, you have to host it. And every inference that somebody wants to make, let's say you've got 10,000 users and they're going to make an inference every second, you need to have the hosting capable of doing that. So let's say you're Facebook and you're trying to train models that predict posts that users want to see, or you're Netflix and you're trying to predict shows that people should watch next. You have to host that entirely. Now, in order for you to do that, you need data from your users, and you need a decent access to that data from your users. So they have to share it with you. Now, with something like TensorFlow.js, that's simply not the case. So all you need to do now is host a 40 megabyte model, or maybe it's a huge model, and maybe it's 500 megabytes. Either way, that's all you have to host. You don't need the processing power to actually run the model. You just need to share it with people. And then your clients, they don't have to share the data with you. They could share the data with you. It could be some sort of opt-in scenario, but they don't have to. So they can have full control of their data, yet still have a custom trained model that serves them content, or whatever. It does it completely catered to them, but they don't have to share any data with you. Also, there's all kinds of other things, like rather than serving ads, maybe you have people finding cures for cancer, or just detecting cancer early for people, or whatever, right? There are so many different things that this just really brings into the equations now. So anyways, I think it's super cool. let's go ahead and get into it. Hopefully someone will mark a timestamp for everybody who doesn't care about all that information. I'm sure somebody will post one. By the way, tutorial starts here. Okay, so what do you need to know to start? So don't post a timestamp yet. What do you need to know to start? You should be familiar with deep learning. So if you're not familiar with deep learning in TensorFlow, I strongly suggest you stop here and get somewhat familiar. At least understand that there's a million sources that can show you how a neural network works. But here's just a super quick overview, hand-drawn by yours truly. You've got your input layers, you've got your output. You want to map input to output the way neural networks work. You've got your nodes right here. These little lines, each line has a weight associated with it. Here's your weight, like this is an input node, input node, input node. Each one connects here, has some weights associated with it. So these weights multiply the value here. There's some sort of activation function. Either it's beyond a threshold or it's lower than a threshold. Basically, it gets a little more complex than that. But anyways, the idea is to, over time, optimize these weights to make this input equal this output. There you go. Neural networks in like 45 seconds. And then other than that, you might want to become familiar with TensorFlow, but honestly, it's not really that required, especially for this series. So with TensorFlow.js, there's like two major ways of making use of TensorFlow.js. You've got the core API and you've got the layers API. The layers API is kind of there to act like Keras, whereas the core API is there to act like TensorFlow. The coverage, as of the last time I looked, it's about 90% with the things that you can do in TensorFlow on Python, let's say, you can do 90% of those things in TensorFlow.js. So unless you're like on the bleeding edge, chances are you could do it. Now, so the other thing too to keep in mind is like, I don't know much JavaScript, so there's a lot of operations where I'm like, how would I do that in JavaScript? And then I remember, I probably don't have to. I can actually do it with what I know in TensorFlow and use TensorFlow functions. And so it's actually saved me quite a bit. The one thing we could not do, I want to say it was random or I think it was shuffle. I think we were trying to do shuffle. There's an operation to shuffle or do random in TensorFlow, and it just doesn't exist, unfortunately. The other thing to keep in mind is TensorFlow does a lot of the same operations as NumPy, so you can even go that far. So if you can figure out how to do it in NumPy, chances are you could do it in TensorFlow. Chances are you could do it in TensorFlow.js. Okay. Now we're getting started, so you timestamp folks. Someone could post the timestamp. So what we're going to do is we're going to start with your typical HTML stuff. Let me figure out where to put my microphone here. Okay. So in your typical HTML, you've got your head tags. Awesome. You probably should start with some HTML tags. HTML. And then even though it's not Python, we probably should use the white space and be good. And then besides your head tags, you're going to have some body tags. So the stuff in your head here is just going to be the things that we're going to use. So like scripts we're going to import. Now let me go over to TensorFlow.js. TensorFlow.js. So you can just do like a Google search for TensorFlow.js. It's otherwise known as js.tensorflow.org. We'll go to getting started, and this is what we're looking for. So you probably want to make sure you get the latest version, but take note, I'm using 11.6 or 0.11.6. So if something's not working right or something's changed, chances are you just need a different version. You like use the version I'm using, or you can figure out what's changed and how to overcome that. But anyway, let's paste in our script tags. So this is all you have to do to start using TensorFlow.js. Super cool, and now boom, works with everybody. Now the next thing I'm going to do is we're actually going to run this in the browser. So go ahead and save that, and then like right click this and then open in Google Chrome. So if you don't know how to do that, let me pull this window over. You can just like right click, open with Google Chrome. You can probably use Firefox or your other favorite browser, but what we're going to do is we just want to run a console. So at least in Chrome, that's F12. And then you come over to console, and then you get this little console window here. Let me see if I can take the whole thing. So we're going to kind of like code this live just to get the idea for interacting with TensorFlow.js. Obviously, this isn't how you're going to actually interact with TensorFlow.js, but this is just a good way for you to get familiar with how things work. So first of all, to use TensorFlow.js, first you're going to define a model. Now, in our case, we're going to be using, I mean, you could use other operations in TensorFlow.js actually without defining a model necessarily, but anyway, constant model, and because I've already written this before, it just, I guess, remembers what I've written, but sequential. So all we're doing is we're saying this is a constant here in JavaScript. Its name is model, and then the model is just a tf.sequential model. Now you've got two choices for models. Let me pull those up again. Let's see if I can get there. I think it's an API reference probably. Model, yeah, you've got sequential, and then you've just got model. Now sequential is your traditional feed forward back prop, just your cookie cutter deep neural network, okay? If you want to be able to do like bidirectional or something like that, you're going to have to go with tf.model and get a little more explicit with things. Anyway, so we're going to go with a tf.sequential model. Now, the next thing we're going to do is add in layers. So first I'll just do this. Oh, tf not defined. Really? No, we should definitely get away with that. Maybe I need to refresh the page. I might not have refreshed it. Let's try again. Can I do this? Yeah, okay. So that happened because I did this saved, but this was already open at the time. So I just needed to refresh. So the return is just undefined. It's all happening out, often in abstract space, so you're not really going to get anything back here. So the next thing we want to do is once we have a model defined, we can just immediately start adding layers. So the first layer to any model, well, that's going to be your input layer, right? So the first layer we're going to have is going to be right here. So it's just whatever we're going to feed in. And then you've got your hidden layers, however many you want, and then the output layer. So in our case, we're just going to do a simple linear regression here. So we're just going to do model.add, and then we're going to say tf.layers, and in this case we'll do .dense, and then you're going to describe that dense layer. So how many units does it have? 1. So it's just going to be linear regression. So you're just going to take in one number, and then you're going to do an output. So in this case, we're just going to do 2x, basically. So the input, let's say, is 2. We expect the output to be 4. Input 4, we expect the output to be 8. So units 1, and then we need to specify the input, input shape 1. That's the other thing. Most of the syntax in the naming, or like the names of things, are the same. You just have to change the naming convention. So we're back to camel casing if you're in JavaScript. Now, so that's our input layer. Since we're doing linear regression, we really only need, and whenever you're actually coding this in actual JavaScript in Sublime or wherever you're coding it, don't forget your semicolon. Anyway, so we've got our input layer. Now we really just want to have a single output layer. So the next thing we're going to do is, or actually, Maddle. So we don't want we're going to have a single hidden layer because that's all we need for linear regression. Wow, why can't I type here? There we go. So now let's do model, and in fact, let me just take this model.add. Let's say units 64. The input shape will still be 1, and yeah, that's good enough. And then let's do model.add, and in fact, let me just do this again, actually. Boom. Units, we'll make this, it needs to output to 1 because we're looking for a single number out, and then the input shape is coming into it, would be 64 in this case. So now what we're going to do is we need to specify some values basically for this. So we've got the model, we know, we've told TensorFlow, hey, it's a feed-forward neural network, but how are we going to actually do the backpropagation and the optimization basically for the model? So we're going to say model.compile, and in compile, again, you're going to have basically a JSON of elements, not write it, loss. So how are we going to calculate the loss? In this case, we're going to go with mean squared error. And then what optimizer are we going to use? We are going to use stochastic gradient descent. The other thing that you'll probably, if you're super familiar with neural networks, I was hoping to pull up the tutorial. Here we go. Obviously, what we've got here is pretty clear, but then here, the only thing we don't really have yet defined is the activation. We'll talk more about activation in the next tutorial. Right now, we're just going to use the default. I'm actually not sure what the default is. It might be rectified linear. I really don't know. I'm not sure if the docs are going to tell us. Let's try tf.layers.dense. Let's see if we can just go to layers. Models, layers, basic, dense, activation. I don't know. I'm not seeing anything that's telling me what their default is. It's, all I know for sure it's a linear activation. But anyway, we'll talk more on that later. But it's just another parameter you'll add into here. But for the sake of simplicity, we'll continue on. So at this point, once we've defined how we want to compile, now all we need to do is pass in basically some data. So we need some x's and some y's. So constant some x's. And here we'll do 1, 2, 3, 4, and 5. And then we'll do constant y's equals 2, 4, 6, 8, 8, 10. So those are your x's and your y's. And then now we're ready to actually train this model. Let me make sure we don't end up going off the screen here. Okay, good. So then we're going to say model.train, or no, model.fit x's, y's. What did we do wrong? Oh, we need to, darn, I'm gonna have to rename these again. I'm pretty sure I did the exact same thing. I can't remember for sure in the live stream. So these are just, your typical JavaScript array, which is unacceptable. You need to convert those to tensors. So what we should have done is constant x's. We're just not going to be able to change this right now, but that's okay. We should have said const x's equals tf.tensor. In this case, it's a 2D tensor, and then done 1, 2, 3, 4, 5. Okay, that's what we should have done. But the other thing we could also hopefully get away with is just model.fit tf.tensor 2D x's. tf.tensor 2D y's. Oh, I guess we also need to assign our shape. If you didn't know, I'm new at this. So aside from, I think we could get away. I wonder. I just want to play around here. Could we do that? Yeah. So interestingly enough, common convention with deep learning stuff, at least in TensorFlow, is to be super explicit as we possibly could be. There's a few reasons why we do that. One is for debugging purposes. Two is for just trying to get things to be as efficient as possible. So it's no different than like how do we speed up Python when we use something like Python? Well, we give them types. So no longer does the language need to figure out like, oh, what is this thing that you're passing to me, right? So those are two reasons why you generally want to be super explicit. So what we're doing in model.fit is we're just passing a tensor, right? We're not being explicit at all. When really, so we did get away with this, but in general, you'd probably want to go tensor 2D x's, and then in this case, the shape should be, so it's how many, so shape, it's so easy to get confused with this, but it's like, it's not width by height, it's like height by width by depth, I want to say. But in terms of samples, just think of it, it's always how many samples do you have, and then what is the shape of those samples. Okay, so in this case, it's 5 by 1. So then if you did the same thing over here, y's, what's the shape of the y's? Well, it should be 5 by 1, right? And that's why we want to be super explicit. Not only do we want these tensors to be 2D, they should also be shape 5 by 1. The other thing you could always say here is you could just do length, like get the length. I think it's like dot, I forget what the syntaxes in JavaScript, but you can get length similar to how you get length in Python to make it dynamic. Anyways, hit enter. Okay, so what you get back here is this thing called a promise. What the heck is a promise? A promise is at least the way that I see it. I could be totally wrong. I'm not a JavaScript programmer, if you guys couldn't figure that one out. But the way I see it, it's very similar to it's just asynchronous. So the idea here is that you can keep doing other things while a model is fitting. So while a model is fitting, you could do all kinds of stuff. You could at least not freeze the web page, right? But at the same time, before you use the model, you want to make sure the fitment is actually done. So a promise basically is either unresolved. I'm trying to. I want to say there's like 3 categories that it could have. But anyways, it's either going to be resolved or you're going to be waiting for it. I guess it could resolve error or be unresolved. I'm not really sure. Anyways, some sort of JavaScript expert could let us know. Anyways, we have fit the model. Now we're ready to predict. So model.predict. And then again, we need to pass a tf.tensor2d into that prediction. And what are we going to predict? Let's try to predict a 6. And again, we need to pass the shape. It should be a 1x1. And you'll see here what we get is something that, at least to me, makes absolutely no sense. I don't see anything here that tells me what I'm actually looking for, right? And what's going on is it's just like in TensorFlow. Everything is abstract. It's we don't have access to it, right? At least for me, this is all running on the GPU, and it's very inefficient to pass data to the GPU and get it back. So we only want to do that when we absolutely need to. So we've got 2 options here. One, in the console, we could actually just say .print. And that tells us the answer it's giving us anyways is 1.74. Not really what we were looking for, but anyway, that's one way that we could do it. The way that you're more likely to do it is with data sync. So do data sync. And then there is your answer that way. So data sync is what's going to get all that information about whatever it is that you're referencing here. That's going to bring it to the forefront. So that's not what we're looking for, right? We're looking for a 12. And so first of all, we don't really have that much data, but this is a perfectly linear question, so we should totally be able to get the answer. And in fact, because it's perfectly linear, I don't really think that we have any concern with overfitment. So what should we do? Well, we should probably go for more epochs or change the learning rate significantly, but probably just more epochs or epochs. So all we're going to do is go back to model.fit and then model.fit, sorry. And what we're going to want to do is you've got your X's, your Y's, and then we want to pass a third parameter here. And this can take quite a few other things in it, but for now we're just going to pass epochs. So we're going to say 150. Another thing that this could take, just making sure I'm not off screen, is something like, do we want to shuffle the data, which is a pretty cool little feature. And so we could say true. And in fact, I think that's a lowercase t for JavaScript. Okay, so we fit, trained. Let's make our prediction again. Okay, so we're getting a little closer to 12. Awesome. The next thing that we could do is rather than train it, let's train it for 1,500 epochs. Oops, darn it. Let me go back. 1,500 epochs. We're waiting. Are we still waiting? We're still waiting. For some reason, I thought it would say promise unresolved, but we actually don't see anything here. I guess we're just simply waiting. Interesting. Should be like 10 times. Why are we still waiting? There we go. Wow, that just took a while. All right. Anyway, model.predict. Okay, we're getting pretty darn close. Eventually, we should get almost there, or at least 11.9999. Let's try like a number that was nowhere near initial. Okay, so 40. Let's try 200. Okay, cool. So, we've got a simple linear model. Now, obviously, first of all, this isn't really where you're going to be doing your coding, but I do find that this is a good place to do a lot of your debugging. At least that's how I learned TensorFlow.js. I would just code up to the point where I knew the code that I wanted to use, and then I would pop into the console and start adding things and seeing how that would impact things. So I think using the console is super useful. And then obviously you've got your little errors that you can see in here too. So chances are if you're writing in here, you're probably going to always have the console up too, just to see what errors you produce. Anyway, a long intro, but there you have a super basic introduction anyways to TensorFlow.js. Now the next thing that we're going to do is make a really simple web application that uses TensorFlow.js to power it. And then we'll get into some more complex things like in this case, we just trained from scratch. What about loading in models? What about training models in Python, transferring them to TensorFlow.js? What about like saving the models and interacting with JavaScript and getting that to work with your model and all that and waiting for training? So anyways, we've got quite a few more things to cover for sure, but hopefully up to this point, everything is making sense. If you got questions, comments, concerns, whatever, feel free to leave them below. Thank you to our recent sponsors. If you didn't know, you can sponsor the YouTube channel, that beautiful blue button underneath the video. Some people don't have it, depends on what country you live in, I think. But if you want to support the channel, you can do that. You get a little badge in the comment section, and then you also get access to videos just like this before everybody else while I'm waiting for monetization status. And also, you get to vote on future content, stuff like that. So anyways, that's all for now. I will see you in the next video.